Hello, and welcome to episode 15 of Cooking with Unity. So, first off, I just wanted to apologize that all the weirdness with my videos recently. Justin.tv recently rolled up an update that had a few problems here and there. I've been working with Dylan Reichstadt to make things right, and he's been doing very well on all that, and I just wanted to give a shout out to him because he's really helped me out. Good German name like Maximilian Wolfgang, but yeah, thank you again, Dylan. Really helped me out. So, first off, last episode, if you remember, or if you were even able to see it, I lost all my work because I didn't save my level. So the very first thing I'm going to do is I was thinking of walking people through how to write an editor script for autosaving, just to save me some hassle. And when I was searching for how to actually do the time stuff, the example for editor application.time since startup is an autosave script. So I'm going to very quickly just grab this one and stick it in a script here real quick. So let's see how easy this is to work with. So we need, first of all, any editor scripts need to be in a folder called editor. It doesn't have to necessarily be just immediately editor, like you could have a nest of folders and then a folder called editor, but your editor scripts have to be in a folder named editor for some reason. So let's go in this here, do new C# script. Well, wait, actually, I think this example is Java, isn't it? No, wait. Yeah, no, this is Java. All right. Delete this. New JavaScript. And we're going to call this autosave. Actually, it probably has to be called simple autosave. Let's do that. I'm not sure if that rule exists on JavaScript. I don't do a whole lot of stuff in JavaScript. There's nothing wrong with it as a language, though. Whatever you're comfortable with is what you should be working in. I just do C# because it's pretty common these days and pretty useful even outside of Unity. Alright, so throw this in here. Yeah, we don't need pragma script, just strict. Alright, let's see if this actually does something. Example, simple autosave. Alright, so I'm going to hit play just so that we compile stuff. Alright. And there we go. Example, simple autosave. And this is just a little window thing. I'm just going to dock it in somewhere. I'll just put it next to console. And this will just save periodically for us. So I'll make a fancier one later in a special episode, but for right now this will work, and now we don't have to worry about me being an idiot anymore. So, all right, we'll see if that actually works when it's that 300. We'll probably just get a ton of errors and the game will crash or something. So where were we? We hit play, move to the right. How do we jump? Did I make it Z or something stupid? I thought I made space. Why can't I jump? Jump power 400. Space. Oh, I'm not sure if nope, we didn't tag the ground. That's the problem here. Still kind of fixing the little problems from last week's episode. That's really embarrassing, actually. So the file, you can't jump initially. That's unfortunate. All right, so there we go. It's working now. Can't double jump. Good. And we only have 2 obstacles, but we'll fill that in with more stuff in a second here. And we need to fix this problem. We're going to do this first. So what I tried to do at the end of the episode was make a object that kills the player, like a spike, And since I didn't want to do any modeling for the episode, I basically just turned a cube on its corner so it kind of looks like a spike. It's the world's worst looking spike, pretty much. But it's red, so you know to avoid it, I guess. So the problem right now is the script I have on the spike destroys, well, rather, the script I have on the player gives the player when, oh, I've got two of these, I don't need two of these, when it touches the spike, anything marked as spike. And the reason that the renderer just stops rendering is because our player contains our main camera. So the moment that we destroy the player, the main camera gets destroyed. So instead of parenting the main camera, we're going to actually make it so the main camera has a script that follows the player. And this will allow us to be more flexible with the way the camera works anyway. I'm not sure if I'm going to be really fancy with the camera work tonight, but I do want to get this fixed so that the player actually explodes properly. So let's see. Player, main camera. So we're going to move the main camera out of the player. Come on. And we'll see what happens when we hit play now. We should just get a camera that's stationary. Yeah. Okay. So we want the camera to follow. So let's make a camera follow script. Create C# script, camera follow. There might be a good one built into one of these things. Potentially. I think the character controller package may have a camera system, but we're just going to make a really simple one and then work on it. Alright, so camera follow. What we're going to want is, let's start with just making the camera follow the X and the Y of whatever we want to follow. So we're going to call this public game object target. And all we're going to do is, in the update loop, we're going to set the X and Y of the camera to the object, and the Z to a constant. So this is just a little hacky way, but we're going to make this a better script as we go along. So let's see. We just want transform dot position equals target dot position. Oh, dot transform dot position. So this sets our position to be the same as whatever the object is, and then we're just going to, actually, we don't want to do it that way. Let's do vector 3 new position equals target dot transform dot position. And then new position dot z equals, what did we have it set to? Well, let's make it a variable so that's useful, but I still want to know what it was set to. Where's our camera? -8. Alright, so we're going to do public vector 3 offset. Actually, let's do it simpler first. Public float z position equals -8. Transform new position dot z equals z position, and then transform dot position equals new position with one n. So what this should do is every frame we're just changing whatever the script's attached to. It says camera follow, but really we can attach this to anything, and it will follow the X and Y of whatever it is but the Z will be set to whatever we set Z position to. So let's give it a shot to see if this works. Now this will follow its centered, which we don't want, and I'll show you how to fix that in a second. Let's see if this works. We just want to put our camera follow script on our main camera, and then we set the target to player. And we hit play. And so now it's following. That's good. And when we hit, alright, we gibbed. That was a very strange gib. We're going to fix that in a second here too. But at least it did. And now we're probably spamming, yeah, every frame now we're spamming that we don't have a game object. So let's fix both of those things. First, let's fix that little bit of spam. So if target does not equal null. So this will make it so if the target doesn't exist, the camera won't do anything, as opposed to spamming an exception. So if we hit play now and die, waiting on my computer here, there we go. So we die, and no more spam. Our console's looking good right now. So, what was the other problem? Oh yeah, we want our gibs to actually look good. So let's make the player, let's actually make a gib for the player. So I like red for gibs, and I like cubes. The main reason I do cubes instead of spheres for things like this is because when I'm prototyping, I'm assuming that when I make a final version of a game, I'm going to have optimized polygon counts and stuff. And so when I start things up, I usually use cubes because the sphere has just a ridiculous amount of polys associated with it. And it doesn't really need them. And so I just use small cubes to start it off because I'm probably going to replace it with something similar in complexity to a cube. Probably a little bit more complex, but you understand what I'm saying. So the cube just means that I'm not going to be worried about performance on the... I mean, like, it improves the performance when I'm doing my little test cases. So we're going to create a new cube. We're going to call it Blood Cube. The new hit movie. See it this weekend. Alright, Blood Cube. So, what we need on this is we want a rigid body on it. We're going to use the gravity on it because we like things to splash out. And what are we going to do with it? We're going to make it red. So we're going to create a new material. Actually, no, we have a red material. So we just throw this on our blood cube. And we're going to make it really small, like 0.1. And just for safety's sake, we're going to put it at position 0. Doesn't really matter. And then we're going to create a prefab for it. Blood cube. Alright. We're going to delete blood cube here. And now we're just going to, on our player script, we have this gib on collide thing. We're going to replace the obstacle with a blood cube. We're going to up that explosion force because we want it to pop real good. And we're just going to make it so there's 20. Oh, whoops. Not what I wanted. Oh, that filled out nicely. Alright, well, we made this extra thing called a mount that just duplicates whatever's in the gib. So we can just do 20, and it'll create 20 blood cubes. If we had 2 blood cubes in the list, it'll create 40 blood cubes. If you were creating a Mortal Kombat style game, you'd probably have in your list like 1 skull and 16 femurs and a rib cage, and call it good. But and then you'd have, you know, a lot of bones spewing the area. But right now we're just using a very simple case where it just blows up like a little particle effect, basically. We honestly could use a particle effect, but I don't feel like braving the editor right now. Alright, cool, that worked. It also hit a few other things. Let's make it so that these things only collide with the ground and nothing else. So we're going to go ahead and click on, where is it, blood cube, and we're going to tag it. We're going to add a tag. We're going to call this blood. Just make it simple. And then we're going to go back to blood cube and actually assign it to blood. And then we're going to look at the collision matrix here. Project settings, physics. And we're going to make it so, layer. Sorry, doing the wrong thing here. That's fine that we have that too. Let's go back to our blood cube, go to layer, add layer, and we're going to do blood. And then we're going to actually assign it to that layer once again. I'm going to hit save manually, even though I think it's been auto-saving. But, yeah. And what else are we doing here? Oh, yeah, just edit, project settings, physics. And we want blood to only collide. We don't want it to collide with itself. We don't want it to collide with default. We should only collide really with, I don't have a ground layer. Let's do that real quick. Ground, layer, add layer, ground, and we could make it collide with nothing, but it's more fun if it kind of hangs around. We might even do something where it doesn't reset the whole level or something, so you can see little blood stains effectively wherever you've died. Where are we going again? So, blood cube, layer blood, ground, layer, ground. Finally, we go one more time into physics, and we just make it so the blood collides with ground. And really nothing else. Oh, wait, what am I doing? I'm being crazy. So we want blood to collide only with ground. So blood, we don't want it to collide with blood. We want it to collide with ground. We don't want it to collide with any of this other stuff. Alright, there we go. So now when we hit play, it shouldn't trigger anything else. It should just explode. And there we go. One of those seemed like it went through the ground, but that's probably just because it had a certain velocity or something. So now we make a little splat there. Alright, so right now, once you die, you die. So let's fix that up real quick here and make it so we can restart the level by hitting something. As a matter of fact, let's go super simple on this for right now. Let's just create a C# script called reset level on. Is it an enter key or return key? I'm going to use return. Reset level on return. And so what we're going to do in this script is going to be a quick little 2 or 3 liner here. We're just going to check to see if you've touched the return key. So if input dot key get key down, is that what we want? Yeah. No. Yeah, get key down. Key code enter. Oh, we don't want enter. Return. Key code return. There we go. So if we hit that key, we're going to reload our current level. So application.load load level loaded level. Oops, application dot loaded level. Nope, that's an integer. That won't help. Well, maybe it will. We'll just do load level name to be safe. So this should, this will probably not work the first time we do it because we need to actually add the level to project settings, but let's see what it does first. So here we go. I'm going to die. Alright, and I hit enter. I hit return, I mean. Maybe that's not enter. Alright, well, it didn't seem to do anything. I would have expected some kind of... I'm going to try keycode.enter real quick. Let's see if this works for me. I'm on a Mac, so I don't know. I know that they like to consider their keys a little bit differently for some reason. Oh, duh. Of course it's not doing anything. I'm going to go back to return. I didn't actually attach it to anything, so we just need this on something, so I'm just going to put it on the camera. So now I get in here. We die. We hit enter. Totally worked. First try. Awesome. And actually, if you just hit enter at any time, it'll actually reset. But at least we have a quick way of resetting that we don't have to like keep hitting play and pause on the editor. That's just a quick and dirty one. We'll want to be a little bit fancier with it. Maybe check. Oh, that was funny. Just why? I thought we put gravity on these things, the ones that pop up in the air. Maybe let's fix that. So obstacle, we want it to have gravity. Let's see how it looks now. Bam. Let's see what happens if I jump on it. And I'm terrible at this game. Alright, let's reset and do it again. Good enough for me. Actually, it looked kind of cool. Like it was supposed to do that, which it kind of was. Alright, so let's do a little bit of organization here because we're already getting... Oh, what the heck? Autosave? Oh, it's... Huh. I don't like this autosave script. Oh, goodness. Yeah. Let's go into the test level again. Did we lose anything here? Yeah, we did. Alright, I'm gonna look at this stupid autosave script real quick. Current scene.split. No, let's just save to the one that we're working on. Editor application. Current scene dot. Okay, so that's just a scene name. Alright, let's just get rid of this portion and see if it operates nicely. So we're going to, first of all, I'm going to make sure that we're looking good on this latest save. Come on, play. Go ahead and close simple autosave and then open it again just to make sure that it doesn't, that it's actually going to work. And I'm just going to delete test level. Yes. call this test level. And we're going to delete these autosaves. Sorry about this. Alright, and hopefully it'll just save to the test level now. What are we doing? I'm just going to try something. Hit save scene. So that little dot goes away. I'm going to change something in the scene slightly. And we'll just see if that goes away once this goes down. Alright, so while that's happening, let's reorganize things. So, we've got materials. We're going to put a new folder, textures. We're going to throw abstract in there. We're going to create a new folder called scripts. Scripts, not scripts. And then we're going to put all our scripts in there. And then we're going to throw all of our, still got that in there, good, right? We're going to throw all our existing materials into materials. And then finally we're going to create a folder called prefabs. No, not an editor, just right there. Anywhere? Come on. There we go. And we throw our prefabs in there. There we go. That's much better organized. And we still have... I'm so going to miss this. We still have another minute, few minutes, minute and a half. Where are we? So we've got this. Let's do a few more things. Let's just make more obstacles. Oh, I remember why we turned off gravity on these things. We wanted them to be able to float. So right now they won't. If I was to move this one up here, we can't block you vertically. So let's fix that real quick. So we can jump this, and you'll see that when I put up at the top, it's actually fallen onto the ground. So let's change that. What are we going to do? We're going to, let's see. We're going to make it so these things start as kinematic, which means that they don't move around. And then we'll change that in our script. So what script controls that right now? It's the slow down or fall away. Here we go. So we're going to open that up. How close are we on our autosave? 67 seconds. Okay, I've got enough time. Totally not going to miss this. First, let's just see. Okay, there's a little thing there. It hasn't been saved. We'll see if that actually goes away. We're just going to make it so that the rigid body dot is kinematic equals false. So now these things should float and also kick away. So I'm going to hit play again. We're going to see if we got our floating cube and see if they still work. Come on. Come on. There we go. So I kicked it away. Good. 7 seconds. Okay, I want to see if this happens first. So 5, 4, 3, 2, 1, 0. Totally saved. Did you see that? It disappeared. All right. Saved scene. It says right there. All right. Now it's working the way I want it to work. Before it appended auto-save to it. I guess that's good so that you have a whole bunch of saves, but kind of hard to work with. As I said, I'll make an updated version of that on another episode where we actually make it awesome as opposed to whatever that is. But at least it's making it so I'm not going to lose all the work that I've done so far. So let's check to see if that actually worked now. Here we go. So these kick away. They slow down the player. Oh, naturally. Getting too fancy. We should have one floating here, and we hit it. It should work like normal. Excellent. All right. Good enough for me. So here we are. We basically have our basic elements working here. We have the camera following the player. It's following in the center, so let's fix that up real quick. So we're going to make it so that the camera has an offset rather than just basically an offset from whatever it's following. So what am I looking at? Scripts. So let's look at our camera follow script. I wait for it to load. All right. So if target does not equal null, change the position. So what we're going to do instead of our public float z position, I'm just going to comment that out. We're actually going to make it public vector 3 offset from target. And this one will be able to adjust now. So, and now instead of doing new position, we can actually get a little bit fancier here. So we can boil this down to one line. We're going to do transform position equals target dot transform dot position plus offset from target. So if we just hit play immediately, we're going to be stuck inside the player because our vector 3 doesn't have any default settings other than 0 right now. So, yeah, this is actually the view from inside the player right now, looking out. So what we're going to do is we're going to look at our main camera, look at our main camera follow script, and we've got this offset from target. So we want to be -8 away from it. And now we can set the X offset a little bit too. We can do like, so we want it to be to the right. So we can probably just do like 3 here. And let's see how that looks. See, now we have it offset from the side. All this is a vector that is being added to the position of the player. So like, basically we have this player position, and then we have this vector. So it says go over 3, and then go out 8, and that's where we want the camera to be. If you notice, we can adjust the camera's positions and stuff here, and it will no longer mean anything. So like now we've got the camera looking off into space, but as soon as we start the game, it's going to pick up the player and start looking at it. So keep that in mind when you do stuff like this. If you're like, man, I totally thought I changed the camera position, and then you're like, oh, I have a script that's actually superseding the position information here. So really, we could throw this camera anywhere, but we're just going to leave it kind of there because that's where it kind of is. So here we go. We've got our thing here. So working pretty good. Camera's working. All the boxes are working. Death it works. We can restart the levels. It's a lot of blood cubes for the little I see on the screen. 1, 2, 3, 4, 5, 6, 7, 8. Maybe that's right. All right. So 8:34. We're cruising. So one of the things I was discussing doing was making it so this is automatically generated rather than just set up like a level. And so I'm going to go ahead and keep this test level around, but we're going to duplicate it. We're going to hit Command D or Control D if you're on Windows, and we're going to call this auto level, and we're going to go into it, and we're going to save test level. And so now we're in auto level, and it looks exactly the same. But what we're going to do is we're going to delete all these things. Right-click delete, I guess. I thought I could just hit the delete key, but I guess I can't. So we already have these prefabs called obstacle and spike in here. And we can instantiate these like we've been doing in our previous episodes for various reasons, or just like how we're doing for the blood cubes. We're just going to have it so that they spawn and position themselves randomly so that you can play a complex level that you didn't have to actually design yourself. I mean, you have control over kind of how it works, but yeah, we're gonna just see how to set this up. I'm going to go ahead and create two separate spawners, one for the obstacles and one for the spikes. So let's go ahead and do that. So we're going to do create C# script. We're going to start with the obstacle. Actually, let's start with the spike spawner. Spike spawner. Alright. Let's see, what's the best way to handle this? So our spikes, let's just make a generic spawner. Let's not call it spike spawner. Close without saving. And let's just delete this. Create C# script. Random spawner. Now, there's a couple ways we could set this up. We could have it at the start spawn all the objects and figure out where they're going to be physically, and then when you start playing that level. And that'll work, but the problem with that is if you kind of have a limit to how many objects you can have, and you don't want all those objects to be active if they're running scripts, and a few of ours are. Most of ours are on Collide, so it's not a big deal. But it's probably smarter to just spawn things in off the screen, just to the right of the player, before he gets to them. So like you're not going to see the whole level populate immediately. So let's do it that way. So we're going to have a few variables here. So let's go with public. First of all, we're going to need what we're going to spawn. Public game object, object to spawn. Let's see. Public, let's see. We want this to spawn off the right-hand side of the screen, so let's see. We can figure out the camera position to figure out where it's spawning relative to, so that's what we'll do. Let's figure out the offsets, though. So let's do the horizontal. Let's do the min horizontal offset. That'll be a float. We may reorganize this a little bit once we see if this works. Public float. let's just do horizontal offset, because that's going to be constant. Public float, min vertical offset. Let's just assume that too. Let's just do vertical offset. And so let's start the horizontal offset to, I don't know, 8. Let's do 10 actually. And the vertical offset will default it to 1.0f. Actually, let's call it max vertical offset because we're going to make this random. And let's make it 3.0f. So, we need one more thing. We need the amount of time between spawning. So let's do public float min time equal between spawns equals 1.0f public float max time between spawns equals 5.0f. These will probably not be terribly useful numbers just yet, but we can tweak them later. That's what they're for. So what we're going to do is what's the easiest way to set this up? So what do we have for random? Random, I know we went through this on episode. On unit sphere, inside unit sphere, rotation, seed value. And range. Range is int, right? Yeah, that's not too useful. Alright. So we need to set up timers. One of the easy ways to do this is to just create a public variable that is a float. Public float timer. I'm going to call it spawn timer. And I'm not actually making it public, I'm going to make it private. So we're going to make spawn timer plus equals time dot delta time. We're going to need the start thing, so I'm putting that back in. Void start. So the first thing we do is we're going to roll some random numbers to figure out when we're going to spawn our first object. So we're going to do that by, in the start here, we're going to set up, let's see, private float spawn time, so that we can confuse ourselves very easily. So spawn time. Both of these will set to equals 0.0f, just to be safe. So spawn time is going to equal min time between spawns plus random dot value times max time between spawns. Okay, times max time between spawns minus min times between spawns. So, what I just did here, we have min time between spawns. We always want spawn time to be at least minimum time between spawns. So that's the whole point of the minimum time between spawns. And so we have that. That's always going to be our minimum value, so that's there. And then we add in random.value returns a a floating point number between 0 and 1, which means that if you multiply it by any number, you will get between 0 and that number at the maximum. So the number we're actually multiplying in is max time between spawns minus min times between spawns. The reason we're setting it up this way is because if we just did max time between spawns, this will give us, like in our case here of 1.0f and 5.0f, it would be between 1 second and 6 seconds. So we need to put the min time between spawns there so that we don't add beyond our maximum time. I hope that made some sense. So this gives us our spawn time. So now in our update loop, which happens every frame, our spawn timer is going up based on the amount of time that's actually elapsed, which is what time.delta time is. So if spawn timer is greater than spawn time, then we do our logic here. One of the things we're going to want to remember to do, and I like to do this earlier rather than later, is spawn timer equals 0.0f, and our spawn time again equals this little thing here, because we're going to want to do both of those things. So now this thing will reset once it has exceeded the time. And actually, I'm going to do greater than or equal to, because it's more specific. It won't make a difference either way in this case. Let's see. So spawn time, we've got that reset, and what we actually want to do here is spawn our object. Spawn our object, and then reset timer and time. So we're going to spawn our object. It's going to be instantiate object to spawn. The position is going to be, we're going to figure that out. We're going to call it spawn position, and we're going to use whatever the object's rotation is. So object to spawn dot rotation dot transform dot rotation. The reason I didn't do quaternion identity is because that'll make our cubes always look like cubes, and we have some spikes that we don't want to rotate to the default orientation. So this should use the prefab's orientation. So we have this spawn position. That's not actually a variable yet, so let's make that real quick. Vector 3 spawn position. So we need to set this to something. So we have our horizontal offset and max vertical offset, and we're going to assume a vertical offset minimum of 0. We could always add that as a separate variable and do similar math to what we're doing here, but this will be simple. So spawn position, we're going to first equal this to the camera dot, I always forget which one we want, not current, probably main, is it main or main camera that we want? We'll just try main first. Camera.main.position. No. .transform.position. So we have its position, and then we want to add some things. So spawn position dot x plus equals horizontal offset, and spawn position dot y plus equals, so we want our max vertical offset between 0 and the max vertical offset. So this is super easy. It's just random dot value times max vertical offset, and then our spawn position dot z equals 0. So this should give us an object on our little strip, because our strip's at 0, z-wise, using the camera's position plus these offsets and some randomness here. So let's see if this works. We just wrote a lot of code here, and hopefully we'll get this actually working. So we're going to hit play. And, oh, so in this duplicate of the level, we didn't actually set up the player for some reason. I thought I'd set this up. Oh wait, the camera. That's the problem. So the camera, we want offsets. What did we use on our test level? Let's check that out real quick. Let's first save this. Go to test level. Make sure that it works. It does. All right. So our main camera uses 3, 0, and -8. All right. So let's open up our auto level again. 3, 0, and -8. So I'm going to create a object here. It's just going to be a, oh wait, empty's in here. Game object, create empty. This one's just going to contain our script. We're going to call this the spawner. Actually, we're going to specifically call this the obstacle spawner. And we're going to throw our random spawner script on here. We're going to set our game object to obstacle. And we're just going to set this to 0, 0. It doesn't really matter where it's at, but that's where I'm going to put it, because we're not actually using this position for anything. Yeah, let's just use those default values and see what we get. So we hit play. Alright. It's working, but our prefab is actually screwed up. So evidently when I adjusted the obstacle, I didn't adjust the prefab for some reason. So we want this to be is schematic by default. So now we're going to hit play, and hopefully we'll see blocks at various times in various positions. So, yep, there's one there. Can I fit under there? Oh, yeah, limbo. Limboed that. Whee! So now we have a little bit of a randomly generated level. It actually worked out better with the default values than I thought it was going to. I swear I can see them pop in slightly. No, I think that's just my imagination. Let's actually look at the scene here. So let's find our player. Where's our player? Focus on the player. No, come on. Focus on the player. There we go. So yeah, you can see them popping in now, and you can see the ones that we already have kind of still stick around. We can add a script to fix that, but yeah, you can see that they're actually spawning just outside of this view range. It's kind of cool, isn't it? Should have the yodeling music from that Price is Right game while this game plays. All right. So we have an auto level, kind of. Now this level does have some problems. It does end. Our platform that we're on has a limited length, so we'll probably want to fix that up in the next episode so that it's truly like that. In the last 5 minutes here, I'm just going to quickly set up another spawner for our. We're just going to duplicate this. And we're going to call it Spike Spawner. And it's going to use the exact same script, which is why we made kind of generic, just call it random spawner. So now it's going to spawn the spike. And we want the horizontal offset to still be 10. We're going to make the min time between spawns higher. We're going to make it so you'll only see a spike every 5 seconds minimum, 10 seconds maximum. And we're going to make it so let's just spawn them on the ground for right now. So vertical offset will just set to 0. So they will always be on the ground this time, I think. So here we go. We're moving. This is awesome. There's a spike. Alright, that's actually... I want it to be embedded in the ground, so I guess we're going to have to put a minimum offset to make that nice for the spikes. Oh no! I'm dead. Did I actually see a thing way up there? Oh, that's funny. Alright, so as I jump up, it's actually using the camera's vertical position to determine where to spawn things. So if you jump a lot, you'll get things spawning in the air a lot. So, that's kind of an interesting little problem. Let's see if we can fix that real quick. Where is it? Our random spawner. We're going to... Getting a lot of phone calls. I hope that people can actually hear the show. It'd be great if one of those phone calls was one of my friends is like, yeah, I'm watching your show, but no audio's coming through. It's like a nightmare for me. Alright, so min time between spawns, max time between spawns, what were we fixing? Oh, it's using the camera vertical. So we actually don't want the camera vertical at all. We just want... There, that's what we want. Although we're going to... while we're here, why not? Let's just do this real quick. Min vertical offset. And we're going to set this to 0 by default. So we want min vertical offset plus, basically make it look just like that other thing, minus min vertical. So let's see how this does. So our jumping no longer should affect it. And actually, while we're doing it, let's make it so that the spikes actually are embedded in the ground. Alright, so spike spawner, we're going to set the minimum vertical offset to negative 0.5. Max vertical offset is negative 0.5. So they should just spawn at negative 0.5 no matter what. So I'm going to jump a lot just to make sure that that stuff's fixed. Looking good so far. Looking like it's working. Oh, and... Okay, I did set it to 0. Good. So, that basically concludes our episode. So, I just wanted to throw... another shout out. Our game Proton Pulse is out on the iOS App Store. We're working on the Android version as we speak. If you want to support the show, or if you want to play a cool 3D block breaking game, check it out. It really helps. It really helps us if you buy the game, and we really appreciate it. And if you want to contact me, go ahead and contact me at pushypixels@pushypixels.com with any questions, comments, concerns. I really look forward to emails from you guys. I've gotten a little bit of fan mail, and it's nice. It's nice to get some feedback on things. And I want to make this show so that you like it. So if you have things that you want me to change or add, I'm going to try and do that for you guys. Anyway, I'm just going to go ahead and call it a night. Calling it like a minute early, but oh well. Thanks for tuning in, and good night.